Hello. Today I'm going to be discussing the second iteration of my logistics trains implementation that's taken from the idea of the logistics train network mod. As you can see in the background, what is playing is a demonstration of what this system can accomplish. The general idea of logistics trains is that a train will wait in a depot station until it is required to fill out a service. When a train is required to fulfill a demand, it will be dispatched from its depot station, go to a provider station to pick up items, and then deliver those items at a requester station. This is a very nice, easy, expandable, and adaptable solution to train networks in Factorio. And here, I'm first going to explain it in a brief tutorial, and then I'm going to get into the details of how all these circuits work and why I think it's cool. I'm going to first show you how to build this setup using the blueprint book in the description, and then I will explain how everything works. For the moment, I'm going to start out with this rail base. This is simply going to contain a square depot that can hold a few trains at any given moment, and some rails that I have predefined just to make things easier on myself for this tutorial. The first thing you're going to want to do is look at the logistics trains blueprint book and grab yourself this train groups blueprint. This is going to place down 18 trains. These trains all have their own unique train group. These are all automatically done. I spent a lot of time making these. They're very painful to set up, and I don't recommend doing it. You'll see why we need this many trains in a moment. The next step is to set up a depot where trains will rest. This depot, the only requirement is that it needs to be able to hold trains, and it needs to be able to hold trains of the length you want. For this demonstration, I'm going to be using trains with 2 cargo wagons, so a length of 2. In order to make a depot, I'm going to go back into the blueprint book, grab the depot blueprint, and find a nice rail. I'm going to do it right here. When you click to place it down, these blueprints are parameterized, and you'll have to choose a number of wagons. This number of wagons relates to signal 1 through signal 9, representing 1, 2, 3, etc., all the way up to 9 cargo wagons attached to the train. Note this also relates to fluid wagons. For this tutorial, I'll be selecting signal 2 because I'm working with 2 cargo wagons. I'm going to do this one more time, just as an example for how this is implemented. You know what, I'll fill the whole thing. Great. Now I've placed down 4 depot stations. Before doing anything else, it is important to make sure that you connect all of these stations with a red wire. I know things can get a little confusing, but all you need to do is make sure that these are all hooked up with a single red wire, not green. This is very important. The last step to set up the depot is to go back into the blueprint book and grab this depot manager blueprint. This should be placed down anywhere nearby your depot. It just makes things easier. Also, it's just for me, but lining up the belts will be useful in the future. I'm going to place mine here because it's close to my train network. And all I need to do is make sure to connect the output of either this arithmetic combinator or the selector combinator to any one of the depot stations. Perfect. Now that we have this set up, we'll actually need to connect all of these belts in a loop. This belt is what dictates when trains can be dispatched from depots. You don't need to understand the logistics, just make sure that you have a loop created that allows a full loop just like that. So now it's just a full loop, and that's all you need. You'll also need to place one item down of any type. I'm going to choose a locomotive because it feels like it would be practical in the situation. And now you'll see it's just going to cycle through all of the stations, and that is exactly what we want. This item will continuously loop through this for the end of time. The important note is that this belt must extend across all of your depots. Depots will only trigger once this item passes under their respective transport belt, so you have to make sure the item can reach it. Great. Now, that's all we need to do for a depot, so let's actually start using these trains. Well, I guess placing them down first. To place down a train at a depot, you simply just place a locomotive, followed by any number of train cars after it. In this case, I'm doing trains of length 2, so I'm going to place down 4 trains of length 2. Once again, this does work with fluid trains, but for now I'm going to just be using items. One thing I really like about this depot, as you can see here, is that you can make sure your trains are always fueled because they will always arrive back at a station. Now that we have our trains done, we want to click on one of them and make sure to click this little Edit Train Group on the top left. Here, you'll see that list of all 18 train groups that we placed down at the very beginning. Since we are transporting items and we have 2 cargo wagons, I'm going to select the 2-wagon item train group. This will automatically populate the schedule of the train. Now, the easiest way to, I'm going to also make sure to set to automatic. The easiest way to copy this is to actually shift right-click a train, which then, if you shift right-click, will actually paste the contents of the train. As you can see, now every locomotive is now set to 2-wagon item. Going to keep this on manual just for now. Great. Now that we have these trains set up, we don't have to do anything more with them. These are automatically connected to the network, and there's no further things we have to do with the depot. Of course, expanding the depot would be as simple as placing down more depot stations and making sure that this belt connects to everything. Now, let's actually use this system. I would like to move iron plates from one space to another. In order to do that, I'm going to need an item provider and an item requester station. The item provider station, when placed down, will provide items that are given to it. When I click to place it down, this is also parameterized. The first option is the item to provide, which in this case is iron plates. The second option is the number of cargo wagons, which is the signal too. The final option is cargo wagon slots to fill. For most players, you can leave this blank. However, if you have an item that is really slow to build or to make, then you might want to turn this down. This number can go from the range of 1 to 40, because it represents the number of slots per cargo wagon that must be able to be filled before the station will turn on. In other words, if the station doesn't have 2 full cargo wagons worth of items at 40, because cargo wagons can hold 40 slots of items, then it will not allow items to be picked up. I'm going to leave it at 40. I highly recommend leaving it at 40, but it is an option you can change. When I place it down, it'll place down a lot of things. The main thing to look at is this little display panel here that's currently reading a red square and says empty. That means that there are currently not enough items in this station to allow it to provide items. Also, since this is 2 cars, I'm actually going to copy and paste this, but more importantly, I'm going to make sure I connect both of these with red wire, extending the signal all the way across. For any number of wagons, you would simply repeat the process until you were able to supply all wagons. Great. This is exactly what we want. Now we want a place to put them. That's when the item requester station comes into play. Placing down the item requester station is the same as the provider station. It'll actually ask you 3 things. First, of course, the item to request, which is iron plates, the number of cargo wagons, which is 2, and the request threshold. This represents the number of stacks of items remaining in the depot or in the station before it requests more. In other words, if there are only 800 iron plates left in this system, or if there are less than 800 iron plates in this station, which, of course, 8 times 100, because 100 is the stack size of iron, then the station will request more items. 8 is usually a good number. I also wouldn't recommend changing it. Once again, same as the provider station, I'm going to copy and paste the boxes and connect them with red wire. Perfect. Now that we've finished this, you'll also notice that there's another display panel, which is orange. This means that a requester station is demanding items. This is demanding items because it is under the 8 stacks of iron that it wants in its system. Now, let's actually turn this on. What I'm going to do first, before anything, is check to make sure that my trains are on automatic. And if they are not, I am going to do so right now. The next thing I'd need to do, normally, is wait for this provider station to fill with items. However, with the power of editing, they are now full of items. I'm just using this setup in creative mode that will automatically supply items when I trigger this. That's not important. But what you'll see is that this train has actually automatically come to pick it up. this train was automatically dispatched from one of these stations. It seems like it's this station, and you know a train is dispatched because this light will be on. Anyway, this train will fill up to be maximum capacity, because there are enough items in this depot to supply a train fully. Once the train is fully filled, we will watch it as it travels to the requester station. This will take a moment as it has to do a quick loop, but on the map you can see that it is going to come and it is resting in this depot now. As items exit the train, they will fill up these boxes, and these boxes, once a certain threshold is met of 8 stacks, will turn this blue, and this depot station will now be satisfied. This is exactly what we wanted. We got our iron plates from our provider station and transported them to our depot station. Note that this train has no context revolving around what item it is sending. It just picks up an item of any type and delivers it to its corresponding requester station. Once the train is finished, it will go back to its respective depot station and rest there until another request is needed. Alright, let's start explaining this monstrosity. The first thing I'm going to explain is the naming conventions of stations. Stations come in 3 types: depot, requester, or provider. A depot station is always of the naming convention depot, followed by the number of cargo wagons. While it would be possible to make depots flexible, one issue that I may come across if that were to be the case is if, let's say I have trains of length 3 and of length 2 in my system. What were to happen if a train of length 3 were to end up in my station of length 2? Well, not only would that break the system here as it just did, but it would also block other trains from passing through, which is not what we want. Let me quickly reset this. Alright, perfect. Now, provider stations will always have the name of either material that it is providing, the word provider, and the number of cargo wagons, or in the case of a fluid train, or of a fluid provider, it will be, if I do oil, and then 2, it will be the oil or the liquid it is providing, provider, the number of cargo wagons, and the symbol F. This is the same for the requester, except of course instead of provider it is called requester, and this is important because of the train groups. The train groups that I have down here that you place at the very beginning of the tutorial are very important. These train groups signify where the train should go at any given point. Of course, any train in the logistics trains network should always initially go to a depot of their given size. I am currently looking at the 2-wagon item, so any two wagon trains should go to a depot too. Then there is this interrupt with a bunch of different conditions that I'm going to get into in just a moment. Now, in order to get into those conditions, let's talk about provider and requester stations and what they do. Provider stations are the simplest thing in this entire system. Provider stations, simply, will either enable or disable themselves depending on whether they have enough items to supply. For example, with this system requires 8,000 iron plates because we are trying to fill 2 cargo wagons. Each cargo wagon has 40 slots of storage, and each slot can hold 100 iron plates, which equates to 8,000 items. This math that I just did is actually calculated here. The first thing to note is that we calculate the user's inputted cargo length using 2 combinators. This first combinator contains the values of 1 through 9 with their respective signal strength of 1 through 9, and one of the item that is being provided at the station. These inputs are also combined with the input of this combinator, which contains the signal that the user selected when placing down the station. In this case, this is a 2-wagon, so it'll always be the signal of strength 10. This allows me to plug everything into a selector combinator. This selector combinator will select the 0th index of all inputs given into it. And sorting by descending, this means it'll select the signal of the highest strength. Because this is of strength 10, this signal will always be the highest strength. So, therefore, it will always output the correct signal strength based on the amount of wagons. Then, all we have to do is subtract that 10 off of it, and we have the amount of wagons. This wagon amount is fed into these three circuits. This first combinator determines the stack size of the item. In this case, it's iron plates, so this is going to be outputting 100. This is then fed into this combinator, which multiplies that by the number of slots in it per cargo wagon that we'd like to fill. By default, this is 40, meaning that we'd like to fill every single cargo wagon fully. Finally, we multiply that number by the number of cargo wagons, and output that as the provide threshold. The provide threshold is then sent finally into this combinator. If the number of items located in the depot at any given moment is greater than the provide threshold, then this outputs a signal strength of 1 on the green signal. Alas, this signal is sent to the station. The station uses this signal to set the train limit to either 0, when the station cannot provide any materials, or 1, when it can. The requester station works very similarly to this. The requester station, once again, will calculate the stack size, the input, the actual amount of wagons, and of course the output that it requires, or the request threshold that it requires. In this case, we're multiplying by 8 because we want to wait until there are only 8 or less stacks remaining of iron before requesting more items. There's also these two combinators over here, but I'm going to ignore those for now, so don't worry. Finally, that signal, of course, is sent to here. If the amount of iron plates located in the system is less than the request threshold, then output a signal strength of 1 on green, which, of course, limits the trains to either 0 trains allowed at the station or 1. However, as you may notice, there's also a radar. What's special about radars is that radars allow signals from the logistics network to be sent wirelessly, which is awesome. The signal that is sent wirelessly is a value of 1 when the station is requiring plates. For example, let's just say that I remove a lot of these iron plates. Oh, inventory full. Say I remove a lot of iron plates. As you can see, this has changed to demand, and now this is outputting a signal strength of 1 for iron plates. Without even doing anything, you'll notice that a train has already come to fill the station, which is exactly what we want. This is how the request stations communicate with the depot stations. The depot stations in this version of logistics trains is by far the most complicated part now. This is in comparison to what a depot station used to look like, which is literally just a station. I will get into why all this circuitry is necessary, but first I'd like to actually get into explaining the depot manager. The depot manager at its core is quite simple. The first thing it does is it takes the global circuit network, specifically the green global circuit network, which is what all of the requester stations send their requests on. This is filtered into this selector combinator, which will count the number of signals that are currently on it. For example, if I'm going to use this constant combinator to pretend requests. Let's say that on the signals currently, I have, 1 copper plate, 1 steel, and maybe I need some solid fuel. That means that, in theory, the idea is that there are 3 requests on the network. There is 1 requester station requesting copper plates, 1 requester station, 1 requesting steel, and 1 requesting solid fuel. This will first count the total number of unique requests. This does not update if I, let's say, set this to 2, meaning that there are 2 requester stations requesting copper plates. This will still remain at a value of 3. This will also this is for later, I will explain that in a bit. But this selector combinator, the output is fed into these 2 combinators here. This bottom this is merely a counter. This counter will output 1 every single time an item passes through this top belt. Let me demonstrate that now, just by creating a quick loop. Now, if I place an item here, you'll see that it is outputting a signal of 1 every single time that item is passing through that belt. What that does is it updates this memory cell to increment the value of C up to the signal strength of L. In other words, what this is doing is it is iterating through the array of items at the total array of unique item requests. Finally, this is sent to a selector combinator, in which the selector combinator selects the index of all the signals. As a result, you'll see that this system now cycles through all of the active requests at any given moment. In total, this makes sure that any item that is being actively requested is cycled through the network. This one here is also something I will get into in just a moment, and it has to refer to depots and fetching depots. I'm going to pick this up for now, just to stop that from iterating. And now I'm going to get into the most complicated and most difficult part of making this entire design, and that is the depot station. This entire setup, compared to having no circuits, is necessary for one reason and one reason only, and that is the double dispatch problem. In my previous iteration of designing the circuitry network, one issue that would occur was that if there were 2 active provider stations and a requester station requested an item, 2 trains would be dispatched, each one going to a provider station, picking up items, and then both delivering to the requester station. In theory, this would not harm the system. However, it is extremely inefficient, especially for items, for time, and for the amount of trains on the network. This is a solution to the problem. The first thing that this station does, unique to the previous station, is that it actually binds itself to a train. This means that any train you place on it will actually always go back to it at any given moment. I'll get into how that works in a moment, but the other thing that this station does is it actually will save the item that is currently being provided at any given moment. This is really handy, because what you can do then is output a negative signal of the request. When that negative signal is fed back into this, that means that no other station will be able to pick up that request. Because, for example, let's just say that we have one request for solid fuel. This station detects that there is a solid fuel request and dispatches a train to fulfill that request. That is exactly what we want. When that train dispatches, it will load the value of -1 of solid fuel into this green network. What that means is that when any other station tries to send tries to look through the list, they'll say, "Hey, there's no solid fuel requests. I'm going to just skip it." And this is exactly what we want. So let me try to explain clearly, and if I don't explain this clearly, I do apologize, but this is very confusing, how this works. I'm going to start with these 3 combinators, which represent a memory cell. This memory cell will save the unique train ID of any train. Right now, they are empty. However, if I were to fuel this train and add its station to Depot 2 and set it to automatic, you will see that these have now been populated with a value of T and X. X is the save value, T is the train's unique ID. This is fetched from the station. This read stop train will output the unique train ID associated with the train at its current depot. This is really nice, and you will see why in a moment. Note that I'd like to say that the red circuit network that is attached to the depot is daisy-chained throughout all depots. So if I were to place down 3 depots, I would always connect to the red. However, the green represents the actual local circuit of the station. So whatever signals need to be handled locally is outputted from the station by green, and whatever needs to be outputted globally is outputted by red. The next thing is I'm going to explain this series of 8 combinators. The logic of this circuit flows from left to right, top to bottom. The first 2 combinators here, on the very far left, are actually a negative edge detector. These detect the negative edge of when a train leaves the station. In other words, in simple terms, it just detects when a train leaves the station. When a train leaves the station, this combinator will output a checkmark of strength 1. This checkmark is then passed into this decider combinator here. This decider combinator, when any item, which in this case would be the item either of copper, steel, or solid fuel, depending on what the request is currently at, based on this selector combinator, and the check mark is equal to 1, then it'll output a signal strength of 1 of the item. That is then passed into this selector combinator, which guarantees that the check mark is not selected when this outputs each, but rather the item is selected. This is then passed into this decider combinator here. This decider combinator is a memory cell. This memory cell will store the contents of the item type that the train is currently supplying until the train is no longer supplying it. I will show a demonstration of this in just a moment, so bear with me. The X is the reset signal. When the reset signal goes high, then the value that is loaded into this memory cell will be released. Next is that the contents of that memory cell will go into this arithmetic combinator, which simply multiplies the number in this memory cell and outputs that to the red circuit network. This combinator here is what subtracts the request from the system and makes the request quote-unquote invisible to other depots. This circuit here is what actually controls this station as well. Just like the provider and requester station, the train limit is set to either 0 or 1 based on this little star. This little star is dictated in a couple ways. Well, actually, no, just one way. And pretty much is dictated for when the reset signal is high. So when the reset signal is high, that means that there is no request being supplied, and that means that the station should open up so the train can return. I will explain this in more detail of the actual logistics of how circuits update and configure themselves, because it is very confusing. This final decider combinator, all it does is actually a failsafe. If this station somehow gets a train back to it, and it's still holding an item, clearly this train is no longer supplying an item. So it should release the item that it is currently supplying, which is why this outputs a 1 when t is greater than 0, aka when a train is present in the station, output a negative signal. Alright, that was a lot of words, and I'm actually not done yet because I forgot about this little sneaky combinator back here. All this does is it outputs a I whenever a item passes through the belt. This is what actually drives the train to say, hey, you can actually look for requests to fulfill. Now, we're almost through, but I'm going to jump all the way back to the beginning, and I'm going to talk about the train groups again. So now that we kind of understand how everything works, let's see how the interrupt works. Train groups by default will always have the train resting at the depot station. That is always a guarantee. The depot station changes based off of the length of the train. Of course, I'm going to stick with 2 for now. This interrupt works on a series of conditions. First condition, of course, is that the cargo is empty. When the cargo is empty, of course, that means that the train, you want the cargo to be empty. This should always be the case, but this is a failsafe to make sure that the wrong items don't go to the wrong place. The next condition is to make sure that the train is not at a provider station or a requester station. If you're unfamiliar with what this symbol means, this little symbol is replaced with the inputted circuit network item upon execution. For example, that's kind of a complex way to say that it's replaced with the item that the train is trying to provide at any given moment. The final condition that must be met is that the provider and requester station it's trying to reach are not full. This is where the train limits come into play. A station is considered full if it has a train limit of 0. Therefore, if there is not a requester and provider station that are A, requesting and supplying, and B, just not already full, aka a train is not already being dispatched to them, then the train cannot take off. These final two conditions make sure that the signal that this train is trying to actually supply, so the iron, the copper, the steel, is greater than 0 and is not a negative number. This is mainly a failsafe. And this I is when the item passes under the belt, and this signifies that the train can actually attempt to seek out a request. The targets are pretty simple. First, it will go to a provider station and wait till its cargo's full or there's 5 seconds of inactivity. Then it will dispatch to a requester station, empty its cargo, and go straight back to the depot. Okay, let's look at an example of how this actually works from a circuit level. Once again, I'm back at my example that I had with the tutorial. However, I'm mainly going to be focusing on this left post. Currently, as it stands, we have a single requester that is constantly demanding items. All of these chests will instantly void all of their contents, so that is not important. This, of course, is connected. The provider is connected to this little constant combinator here, which I could turn on to fill the station at any given point, but that's not important. First thing to notice is that since the requester station is currently requesting, there is an output signal of 1 on this system. This is the only item being requested, so therefore it is constantly iterating through the index of 0, which is always outputting this iron plate of 1. Now, this station is fresh, meaning that there is no train attached to it. You can see this by seeing that these combinators have no values compared to something like these combinators, which are storing the value of their current train. Now, let's load a train up by simply setting this to automatic. Once that is done, you will see that these have now been populated with the train's ID. Note that the train's ID is unique. This one is 308, this one is 304. Now, nothing will change yet. That is where this little item comes into play. Of course, when I start to provide an item, then a provider and a requester station will become available, which means that a train can be dispatched. So, let's, I guess, just do that now. I'm going to wait till this comes all the way back. Of course, when this loops, it triggers at each individual station. This provides the delay to make sure that the signal always updates. Let's fill up the provider station. That should be enough. There are some really fast inserters there. And we'll see as soon as this passes in, this train is gone. It is off doing its thing. And you will see that this light has lighted up. The only real change that the system has seen is that this combinator now contains an input signal of 1 iron plate. This signal is then multiplied by -1 and sent to the red network. Since this red network is daisy-chained all the way to the beginning, it cancels out the iron plate input. Therefore, this red actually sees an iron plate output of 0. However, one thing you will notice as soon as this train is done supplying, which will take a moment, is that this light actually turns off before the train reaches the station. Now, you may think that this is an issue, but it actually pertains to the final part of the requester station that I did not talk about earlier. What's interesting about the requester station, and you'll see as soon as this light turns off in just a moment, as soon as the train is emptied, now, you'll see that the light has turned off, and now the train is on its way back, it'll park, and that is everything is good. It's completed the request, nothing more that needs to be done. So, how the heck did that happen? So, one thing I kind of didn't mention in my explanation of the depot is that this green network also can, in some cases, output the contents of a train ID. Just like with the depot, the requester station will actually read the stopped train ID. This is connected to, once again, a falling edge of the train leaving the station. AKA, when the train leaves the station will actually output the train ID of the train to the global circuit network for 1 tick. Let's go back to the depot manager. When that is received by the depot manager, it is then fed into this arithmetic combinator, which multiplies the the signal T, which is the ID of the train, times 1 to make sure that it only goes through the signal one way and not both ways. This is then fed into times 1, and it has the output of the exclamation point. This is where these final 2 combinators I kind of didn't touch on come to play. What this will do is it will add the value of the signal X, which, by the way, represents the stored memory of the train ID, added with the exclamation point, which is the train ID that is sent for 1 pulse by a requester station, and output that as a question mark. When the question mark is 0, aka when the train ID that is outputted by a requester station matches the train ID of a depot, the depot will, first of all, remove its request remove the negative request from the decider combinator, which is important because we want to free that up. And it will re-enable itself to have a train stored at it. One thing I did not mention is that while this light is active, no train can go to this depot because its train limit is set to 0. That is how we make sure that A, trains are bound to a single station, and B, we know how to free signals so that other trains can pick up requests. I know this may have been a little confusing. I'm going to run it by one more time. The idea is we create a provided request. This train item here, I did not add enough items. Let's just add a little bit more. The train passed underneath this train. What I mean by that is this little item passed underneath this cargo wagon and dispatch that train. That train has a light to signal that it is currently dispatching an item and being filled up at either provider or emptying out at a depot station. Once again, the item is stored in this decider combinator in memory, and that will stay in memory until it is finally released when the depot station outputs the train's ID to the global circuit network. Overall, I guess just while this is working, I would say that this was probably a very over-engineered solution to the problem. Of course, as I've been made aware, Logistics Trade Networks is actually available for Factorio 2.0 now. So if you want the same implementation as this without all of the hassle of setting up all of my circuits and the potential performance costs that may come with this many circuits, I would highly recommend downloading that mod. It's what inspired me to make this. Of course, there are still a few issues, and I'm sure there are bugs that I've not run into yet that will make this system bork. One such issue, as you just saw, is that for 1 game tick, a train that is being dispatched will actually not be able to find its depot station. This is not an issue. It can easily find its depot station, but it'll output that really annoying warning for 1 tick, and it'll last for a couple of seconds. So that's one downside to using these circuits. But overall, I'm very happy with what has been made here. It kind of does suit the needs that I was hoping for, and more so just kind of proves the point that this sort of setup is very feasible in Factorio, and that there are multiple ways to use trains in Factorio. I've never been a huge fan of just having trains follow set loops, and the introduction of interrupts really showed me that you can do a lot with these trains now. And it's really taught me a lot of how everything works. I don't think I'm done designing this yet. I assume that when I post this video or when I get feedback from other people, I'll find some sort of stupid thing I've done that could be done with way less steps, way less circuits, and look way nicer than whatever this monstrosity is. But for a second version, I am very happy with what I've made. I really appreciate you watching. I also really appreciate the feedback and engagement on the first iteration of this. I'm super happy that people are also interested in logistics trains in Factorio, and I honestly just think it's a really like underappreciated and underutilized aspect of the game. Of course, it was only available within modding for a while, but now that it's actually a part of the game, I'm surprised that more people haven't taken advantage of the sheer flexibility and complexity that interrupts really allow in this game. So, yeah, thank you for watching, and I appreciate the support.